Jai Hind all of you. I'm Dr. Rahul Bansal from Ajay Kumar Garg Engineering College, Ghaziabad. So this one is the next video lecture for the electron devices KEC 301. So let us start. So in the previous video lecture, we had discussed about the FET, that is field effect transistor. In this video, we will be discussing about the Mosfet, right? Basics of the Mosfet, right? And what are the input characteristics and the output characteristics, right? Of the Mosfet, right? So input characteristics is also called as gate characteristics, and output characteristics is also called as drain characteristics for the case of Mosfet also, right? So in the previous video lecture, we had also discussed about the what are the advantages of like FET with respect to the BJT. We are already having the amplifier that is consist of this BJT, but what are the major advantages of FET with respect to the BJT, right? Now with respect to FET, we are having several advantages of Mosfet also, right? So Mosfet is fabricated using the planar technology, in which thousands of the Mosfets are fabricated simultaneously, right? So cost of the Mosfet is very less as compared to BJT and FET. So effective cost is very less, and it is very easy to fabricate the Mosfet with respect to the BJT. So how does it happen? So let us discuss about this, right? So right. So this structure is the Mosfet structure, as you can see. Right. So this is connected to the metal plate. I will just let you know about what are the drain, what are the source, right? So this side, so this terminal is called as like gate, right? This terminal is called as drain, and this terminal is called as source, right? So majority charge carriers will be generated at the source, and they will move towards the drain side, right? In case of Mosfet, right? So movement of the charge carriers will be from let me use a different color pen for this. So movement of the charge carrier will be from the source to the drain, right? Now correspondingly, drain current will flow like this. So this is the direction of drain current. Now how does it follows? First, so this is actually the P-type substrate, right? And this is grounded. This body terminal is grounded to reduce the noise, right? So this is also an advantage of Mosfet, is that it is noise free. It gives the noise free environment. Noise is actually equal to 0. Minority charge carriers are theoretically and practically they are approximately equal to 0, right? So they are like negligible. Minority charge carriers are negligible in case of Mosfet. So this is also the advantage of this Mosfet, right? So in this type of Mosfet, so why Mosfet is called as Mosfet? Many interview ask this question, why Mosfet is called as Mosfet? Because it consists of 3 different layers, right? First is metal plate. So this one are the metal plates, right? So these are the metal plates usually made up of aluminium, right? Next is layer is oxide layer. Now this layer is actually the oxide layer, usually made up of silicon dioxide, and this will work as an insulator, right? So SiO2 and semiconductor. So this third layer is your p-type semiconductor, as you can see. So that's why this MOSFET is made up of 3 type of like layers. So that's why it is called as a MOSFET, metal oxide semiconductor, right? So during the operation, an electric field is produced, right? So this electric field will control the drain current. So that's why it is called as the field effect transistor, right? So this complete structure is also called as Mos capacitor. So why it is called as Mos capacitor? If I connect this source to a positive terminal like this, right, and we connect this to the drain, this gate, right? So correspondingly, positive charge carriers will be at this side, correspondingly negative charge carrier will be at this side, right? So a capacitor like structure will be formed, and this SiO2 will behave like a dielectric, like this. So this will behave like a dielectric, right? So this will be a parallel plate capacitor, right? So this MOSFET is also called as Mos capacitor because a capacitor will be formed when we apply this gate to source voltage, right? Next is how does it operate, right? So MOSFET is basically of 2 different type, right? So first is enhancement type, and next type is depletion type. Right. In the depletion type MOSFET, right, these aluminum plates are connected. So this this depletion type MOSFET can work in 2 different modes, that is in the enhancement mode as well as in the depletion mode, right? So I can just write here, it can work in the 2 different modes. First is the enhancement mode. So let me change the slide. Depletion type. Right. So first one is depletion mode. And second one is enhancement mode. So when is MOSFET is said to be working in the depletion mode? See in the circuit. Whenever this gate terminal is connected to negative terminal of the battery, that is like this, and this source terminal is connected to the positive terminal of the battery, then this is said to be working, this depletion mode MOSFET is said to be working in the depletion mode. So this type of depletion type of MOSFET is said to be working in the depletion mode if at all this negative terminal is connected to the gate terminal, right? Next is enhancement mode. In enhancement mode, the depletion type in this depletion type MOSFET, this gate terminal is connected to the positive terminal of the battery, like this. So it will be positive and it will be negative this time, right? So this gate terminal is connected to the positive terminal of the battery, and this source terminal is connected to the negative terminal of the battery. Then this is said to be working in the enhancement mode, right? So if you differentiate between these two, if I say like drain current in the depletion type MOSFET, drain current. See, one more thing that I want to discuss is a diffuse channel is there, right? A diffuse channel is there. Here we have this diffuse channel between source and the drain, right? So in this channel, charge carriers will be charge carrier will be moved from source to drain. Correspondingly, drain current will flow from the drain to source, right? So whenever we connect this gate side as negative terminal, right? Negative, right? So correspondingly, here we have electrons. At the upper side, we have electrons, and in this diffuse channel, there will be positive ions. Now, some of these positive ions will be combined with the electron, right? And they will reduce the effective channel length, right? So your channel will appear like this. It will appear like this. If you see this carefully. So if I connect this negative terminal of the battery to the gate, right? So it will so there will be negative ions, and here we have positive ions, right? And they will combine with the electron. Effective channel length will decrease, right? This will decrease the drain current, as now the charge carriers, less amount of charge carriers are reaching from the source to the drain. So this will ultimately decrease the drain current, right? Next is so maximum drain current will flow whenever gate to source voltage is 0. So what we can say, in the depletion mode, ID max will be equal to IDSS. So this IDSS is the maximum drain current flows whenever gate to source voltage is 0, right? Because maximum number of charge carriers are reaching from the source to the drain. Now this IDSS is called as drain to source saturation current. Also, it is also called as drain to source safe current, right? Now in case of depletion mode, ID max, that is maximum drain current, will be equal to IDSS. Now talking about the enhancement mode. So in the enhancement mode, this gate terminal is connected to the positive terminal of the battery, and correspondingly negative charge carriers are available in this channel, right? So that the number of charge carriers in the channel will increase, right? So due to which, in case of enhancement mode, drain current will increase, right? It will increase such that this ID min, that is minimum value of drain current, right, it will be equal to IDSS. So why does it happening? Whenever gate to source voltage is 0, in this case, a constant amount of charge carriers will be reaching from the source to the drain. But whenever we connect the positive terminal of the battery to the gate side, then the number of charge carriers will increase in the channel, so that the drain current will increase, right? That's why we say that this minimum drain current will be equal to IDSS, right? So this is the two type of, like, so these are the two type of this MOSFET, right? Now next is E only MOSFET, yeah, enhancement type MOSFET. So in case of enhancement type MOSFET, these are also called as modern MOSFET. In the modern MOSFET, what we do is we replace this aluminum plate at the source and the drain with a polycrystalline silicon, right? The advantage of using this is area of the MOSFET has been reduced. Also, performance of the MOSFET in terms of the gain bandwidth product and gain will also improve. So we will get better output when we use the polysilicon crystal, and it will make the MOSFET more cheaper and convenient to use. So that's why in the modern days this enhancement type MOSFET has been used. So this enhancement type is also called as E only MOSFET. So I can write here E only MOSFET, right? So in the next video lecture, we will be discussing about the input and output characteristics of also called as gate and the drain characteristics of this depletion type MOSFET and enhancement type MOSFET. So thank you all of you.